Hello, everybody, and welcome to the TAC meeting. My name is Bailey D. Phelps, and I'm the Technical Advisory Chair. And thank you for coming today, and thank you for those who are on the webinar. And I'm excited to invite Steve Hart here today from King County to talk to us a little about the plumbing regulations and plans. So I will let him introduce himself and give some more information. For those in the room, we have these microphones. Make sure to press the button on them and hold it when you talk, and then the people online can hear you as well. So go ahead, Steve. Thank you for coming.
Thank you, Bailey. Well, as Bailey said, my name is Steve Hart, and I work at Public Health Seattle King County as a plumbing plans examiner. This is a new program, and it was felt that there should be some sort of a collaboration with the Puget Sound region design professionals and the plumbing industry here. And so we ventured out and we started to collaborate with the American Society of Plumbing Engineers, the Seattle chapter, to try to create minimum plumbing plan review requirements, something that would be on a set of plans that would help all those who are designing plumbing systems have a insight to what should be on a set of plans and what is beneficial for not only the designer, the reviewer, but also the installer. But before we get too far into the process here, I'd like to talk a little bit about who I am and what I've done that is a part of this process. So like I said, my name is Steve Hart, and I worked as a journeyman plumber for greater than 20 years. And I also worked as a building inspector and a building plans examiner. So I kind of know the buildings a little bit in detail. I have a little bit of knowledge of codes, not only plumbing, but other building, mechanical, electrical. And these different avenues that I've been able to be a part of have greatly increased my ability to not only review plumbing plans, but to converse with design professionals and what could be a best management practice for either the system that they propose or what would be a best management practice for plumbing in general. I'd like to say that plumbing and the industry of plumbing has been a big factor in the benefit to public health. And because of this, well, I guess just to kind of put it in a nutshell, those that create vaccines get kind of the benefit and all the glory, so to speak, for curing a disease, but plumbing prevents a lot of disease. Good plumbing systems, water systems, and sewage systems. So my take on this process for plan review is that I enjoy finding a way to have a safe system, an economical system, and one that comes from sustainability, as well as conserving the resources that we have. So that's kind of where I'm coming from, and I hope that those that are involved in this process would have the same point of view, that we're all in this together. Unlike other programs that are in different building departments, whereas there's building, mechanical, electrical, sometimes there's collaboration with the local design community, but typically the building departments create their own policies and rules and then they move forward. In this case, as I stated earlier, Public Health Seattle King County Plumbing Program decided to work with the Seattle chapter of American Society of Plumbing Engineers in collaboration to create these minimum plumbing plan review requirements. And the purpose behind this is to not be a third party to an already existing system, but to add value to those that design plumbing systems and to really elevate their education and their skill and their talent in creating and designing safe plumbing systems. So with that being said, I'd like to start with our process here and where we're at currently. So as you know, on our website, we have the minimum plumbing plan requirements, but we have also collaborated with other entities in the Puget Sound region. Those entities being McKinstry, Russian Engineering, AEI Engineering, and it's escaping me right now for whatever reason, McDonnell Miller. These four entities are working behind the scenes in collaboration with Public Health Seattle-King County to create development standards that mirror the minimum plan review standards. Those standards are standards that help develop a commonality in the Puget Sound region design professionals' approach to either best management of a design system, but also to include rules, laws, regulations, and those systems that best prevent public health risk at the same time developing the plumbing industry. So these development standards, coupled with the plan review requirements, eventually will become one system. Currently, we are working with our IT staff to create a format that will work and it will be adequate for those who will go to our website and look at these development standards. What would be in a development standard? A development standard would include a type of design criterion based on a detail. For example, let's just say that it was a DWV system in a multi-story structure. That process would have from the vent through the roof to the discharge of the side sewer and all components and piping in between. In addition to this, there are water, storm, and there's also gas pipe systems, including in these development standards. The program on the website would only be completed after all of the development standards were sent out for comment and feedback from the Puget Sound region design professionals. So far, we have added, in collaboration with the development standards, beside McKinstry, McDonnell Miller, Russian Engineering, AEI Engineering, we've also added MCA, Mechanical Contractors Association, who will also help us maneuver through the process to get this information out to design professionals so that they have an opportunity to set the standard in their own industry, so to speak. What is applicable on a set of plans? What is beneficial to the installer? What is a safe plumbing system? And how do the codes apply? All of these are beneficial to all parties. But unlike I stated earlier, in building departments, in this case, the plumbing plan review is actually reaching out to the plumbing industry and asking for their collaboration and their cooperation to meet that criterion that should be on a set of plans for a plumbing plan review. In the past, there hasn't been a plumbing plan review. As far as I've been told, somewhere in the neighborhood of 30 years. But there has been building plan reviews, mechanical plan reviews, electrical plan reviews here in the city of Seattle, but not plumbing plan reviews. So this is a step forward in a new approach, and the approach is to include the design professional industry as we move forward into the process of sustainability and water conservation. All of this ties together, and a lot of the knowledge can be written in a code, but really the talent and the skill to keep a system safe and prevent unwanted or unanticipated issues that may arise, the only way to really do this is to collaborate with the design professional community. So you kind of know where we're at and where we've been and where we're going. So I would like to talk now about the program itself, which is Plumbing Plan Review Minimum Submittal Requirements. As I stated earlier, on the very first slide, we have made a note there that the minimum submittal requirements created in association with the Seattle chapter of American Society of Plumbing Engineers. So we have 4 phases to our ongoing process. These 4 phases are going to be delivered in the same manner that we rolled out the minimum plumbing plan review requirements. And these 4 phases include plumbing design requirements, commercial kitchens, medical gas, and rainwater harvesting systems. So phase 1 here is the phase that we're in right now, which is minimum criteria required on plumbing plans, minimum submittal requirements for 3 stories and greater. This originally was a requirement prior to September 18th of 2015, and it had always been a needed request by then Chief Plumbing Inspector Dave Cantrell to require that structures that were 3 stories and greater be submitted for plumbing plan review. And the purpose behind this was, 1, there was SUDS relief, and 2, that there were systems that were being introduced into the community that were other than prescriptive, that might have concluded maybe a Sovent system, or even the PAPA system, the single stack pressure system. So having said that, in March of last year, as we became more equipped to handle a plan review program by hiring more individuals, we were able to get to work and create phase 1, which is the minimum criteria for plan submittal. We do have a date that we rolled out the plan, which is September 13th, but this is only a continuation of what was already being asked, and that was that plans be submitted for a plumbing plan review. On many occasions, when plans were submitted, Dave Cantrell would review them and then approve or make the adjustments necessary prior to this program, but we actually had no full in-force plumbing plan review program where there was set places to submit, money involved, design criteria for minimum plan review. So this is phase 1, and phase 1 is a continuation of what was already being asked, with the exception that it's not longer an ask, it's now a requirement that if you have a structure 3 stories and greater, that you submit for plumbing plan review. We've also incorporated other portions of what would be considered plumbing plan review, but we also understand that as the community is moving in the progression of construction, that there was really not a good time to roll out the plumbing plan review program. And we knew that there would be a lot of processes that were in design, in concept, or actually finishing a project. So what we did to help mitigate some of this and offset some of the problems was we decided that we would have a 3-phased or 3-prong approach that would allow design professionals, contractors, and plumbing companies to be able to get one of 3 permits. They could get an underground only permit, or they could get a rough-in and final, or they could get a full permit, which is underground, rough-in, and final. And the purpose behind this was that we knew that the structures would be in flux as they were being built, but yet we had to move out with a program sooner or later, and it wouldn't matter if we waited 1 year to do it or 3 years. There would be jobs that would be in the process of being constructed, or the groundwork complete, or the rough-in complete. So we tried to do our best to try to offset that by having these different levels of a permit that would still allow us to do the review, but still allow the individual to continue with the process on their project. So the current policy is that where there are structures 3 stories and more, these structures must submit for a plumbing plan review. Now, there are exceptions to this, and we'll get to that portion of it here in just a moment, but what I would like to say about getting a plumbing permit, it is possible to get a plumbing permit over the counter. and start your project, and then have a inspector show up on the job site and ask for approved set of plans. So at that point, what would happen is the request would be made by the inspector to have a set of approved plans on the site, and then it would be the installer or the permittee, whoever pulled the permit, to submit a set of plans. Now, we don't shy away from the fact that this is kind of a difficult process, but if you submit plans prior to you starting a project, it prevents a lot of issues that are ongoing during your process, such as those are concerned about an impact of a schedule, that if they have a permit and an inspector shows up and the process gets halted, then what that looks like is that we are obstructing a job and basically stopping it. And that's not what we're trying to do, and that's not what we do. We allow a process to continue even though a permit has been pulled. But the correct or the best approach is to submit a set of plans, get the plan approved, pull your permit, and then move forward. But we understand that in some instances, this wasn't going to be applicable and projects were going to be in flux. So that was the reason we created the 3 types of possible ways you could use a permit: underground, rough and final, underground, rough and final. So the exceptions that I was speaking of earlier, when it comes to public health and public health risk, the viewpoint of public health Seattle-King County is this: if a system causes or creates a public health risk, then although the design of the plumbing system may have been in full intent of the code and the purpose of the code, if it creates a public health risk, then it would most likely not be allowed to be used under the rules of public health, where our main and sole mission is to prevent public health risk. By preventing public health risk, this assures the community that they can go into an establishment or be near or a part of a structure and not feel any recourse that might affect them. So when it comes to 3 stories and greater, we require a plan review, but we also require for a couple other things that are directly related to public health. And those are things that you would drink or things that you would eat where there might be an industrial process. So this might be places that would be like industrial places that have marijuana processing facilities, or a fuel dispensing facility, or a research laboratory. There are many more examples, but these are just some that would be industrial. These are types of projects or processes that are high in their complexity as a plumbing system, and they would require a review because it would directly affect public health. Another exception would be commercial projects, such as breweries, embalming facilities, food processing facilities, and again, large complex projects to include motor vehicle repair or even commercial laundries. Now, as I stated, these different types of systems have a direct correlation to public health risk. And sometimes, as I stated earlier, a system may be in full value of its design and the concept based on the design professional's ability to move a medium through piping. But if that medium or that system has a way to cause or create a public health risk, then what would need to be done is a second look would have to be taken to confirm that what is being proposed as a plumbing design would not create a public health risk. So a filter of public health risk prior to the plumbing system itself is basically the point of view that public health is using and takes when looking at systems. So in the event that there was a proposal for a plumbing system, if it moved the needle to a higher level from 0 to public health risk, then more than likely we would ask that plumbing system to be adjusted in order to be able to not have a public health risk. So I want to, at least make the mention that this program is new. It is very new. It's less than a year old. There's a lot of bugs to be worked out, so to speak, in how it's processed as far as plans and fees and requirements on plans and expectations. And I hope at the end of this we'll have some question and answer, but for right now, I just want to inform all that this here program is new. And with any new program, there's always going to be a revaluation, or there's also going to be ways that we need to either mitigate or correct what we are providing for a service. And we ask that you provide feedback and comment to us that would help us develop a sound system that is more in line with general practices of the community in the plumbing industry. We also have exceptions to the plumbing program for plan review. Those exceptions that would not require a plumbing plan review would be single-family homes and plumbing systems that would be limited in scope. So we don't have a definition of what we would consider limited in scope. And the purpose behind that is that we want the design community to collaborate with us and partner with us to come up with what should be looked at as a review and what we could look at where a installer and an inspector would have those experience and that knowledge to approve systems without having them to go through another process, which would be a government process, and that would be a plan review. So as we get further down the road and we get to the development standards and we put those out for feedback and comment, we are going to have one of our questions be, what should be a break line for review other than 3 stories and greater? As I stated earlier, we had 4 phases to our process, and the second phase is the announcement of the development standards, as I spoke earlier about the development standards, and in connection with commercial kitchen plan review. We were doing commercial kitchen plan review until we became so busy that it was just enough to get out and do the inspections. And we had to drop the commercial kitchen plan review, but we intend to fully pull commercial kitchens back into the plan review process. And the scope was that we would do this at the same time that we laid out the development standards for the DWV systems and gas piping, and put out minimum criteria for commercial kitchen plan review. We know that that's a lot of undertaking that has to be done on our side. Again, we'll be looking for collaborators. If anyone out there is interested in being part of this process, please contact Bailey, who can forward me that information if you would like to participate in our minimum plumbing plan review for commercial kitchens. Commercial kitchens can include restaurants, commissaries, restaurants and takeout only facilities, and restaurant facilities in general. So it's kind of a broad area for commercial kitchens, but this is part of phase 2. And just like phase 1 was setting out the minimum plumbing plan review requirements, we would have the same thing for commercial kitchens. And we'd like to try to do this at the same time that we do the development standards. But we're not so sure that it's going to be an overload of information, but we're going to see where it lands at and how well it's received by the design community. Phase 3 of the 4 phases would be medical gas pipe systems. So medical gas permits are not part of a plumbing permit right now. And currently we review level 1 and 2 medical gas systems that do require a plan review. They have always required it for quite some time and currently do. The only system that doesn't is a level 3. We have had some conversations with the Department of Health and talked to them about all of the different systems that they review that sometimes we do not get the opportunity to review. And they have quite a list, including hospitals, assisted living facilities, adult family homes, juvenile detention facilities, and so on. Not all of these have medical gas systems in them, but we have been in contact with the Department of Health, and we may in the future under phase 3 have a little bit more of a ability to participate in the community where we don't do redundant reviews, but we do try to capture what we would consider systems that should have a review. And again, we'll reach out to the design community to help us find out what that is. It's important to us to know that we're working with the community and that we're not setting the standard or the bar or the rules or the regulations, and that we're all working collaboratively to partner to come to best management practices for engineering and sustainability. So phase 4 is rainwater harvesting plans. This is kind of a really open subject here because we have rainwater harvesting systems that could either be for non-potable use or for alternate potable use and all the way to sole source use. So because we have these different levels of rainwater harvesting, we have currently been doing our best to manage how much of the rainwater harvesting should be reviewed. And currently right now, we are at, in most cases for reviews, have been single family homes, sole source systems. However, we have had a few that were alternate here in the city of Seattle that have been approved. And we've also approved a few non-potable rainwater harvesting systems, which were typically, in most cases, used for urinals, toilets, etc., trap primers. One thing about non-potable rainwater harvesting systems is that they must be tested every 4 years for cross connection. That means whatever entity that they are installed in, let's just say for an example, we'll pick a multi-story structure with, let's say, 20, 30 non-potable rainwater harvesting fixtures. Every 4 years, there would have to be a full cross connection to confirm that nothing has been crossed to the potable side. In a large structure, this could be very expensive, and it could impact a business quite readily. So we're looking to the design community to give us feedback on this, how to approach this. Is 4 years too far apart? Is 4 years, is a cross connection test other than the initial really needed? So we're looking for feedback on that and hope to get some. So phase 1. Minimum criteria, as I stated, was provided on September 13th of 2017. And from that time, we have had a lot of plans submitted. And we knew that because what we were expecting to be on plans, and those that have for many years not been required to have certain minimum criteria on plans, that there would be a gap between what we would like to see and what would be submitted. And because of that, we did make a comment in our presentation here for minimum plumbing plan requirements. which stated that incomplete submissions will not be accepted. We haven't really made it to that process yet where we're turning away plans, but there have been plans that have come in that are so lacking that there's just not enough information on a set of plans to even do a review. They may have equipment missing, components missing, riser diagrams not complete, full riser diagrams like maybe a gas pipe system not even included in the plan set. So having all of that said, we try not to turn them away, but if it's just not possible to do a review without making a ginormous punch list, then we sit down and have a conversation and go through the process with whomever is trying to submit the plans and label and mark on their set of plans what is not present that would benefit not only the installer but allow us to do a plan review. So what is required on a set of plans? Well, riser diagrams. What is all part of a riser diagram and what systems are being requested? Well, there would be the 4 systems that we would like to know: water, waste, storm, and gas. Gas not being a plumbing system, but it is a system. So what we're looking for are all of the components that are a part of a system. As an example, a gas pipe system showing the gas meter to the furthest fixture, all the piping in between, the sizing, the loads, all the equipment, and any construction details that would be part of that process. That would be a riser detail. It seems like that when we get a detail and we have all this information on a detail, not only does it allow us to understand the system in this 2 to 4 to 6 hour review that we are doing, that those that had been detailing or designing the system had several months to work on, and they know all the intricacies of the system that's being proposed. We have to quickly get to the point when we're looking at a set of plans to understand what the system is doing. In order to do that, these riser details showing the full system allow us to get to that decision or get to what those that have designed it already know. Otherwise, we have to try to connect the dots and bridge or gap the bridges and all of this in order to understand your system or what you're proposing to do. So the riser diagrams do this for us. They help us catch up to where you are at and what you already know. One thing that we look for, and as an example, sand oil interceptors. There is no formula, there's no method, there's no standard that's been set in the community as to how to design or size other than the actual requirements that are prescriptive in the plumbing code. There's been multiple ways of designing sand oil interceptors that have been proposed. And as of today, I currently encourage each one of them that whatever they're designing as a design criterion is applicable. And the purpose and the reason behind that is because there's no set standard in the community. It's all over the board. In every way, it's all over the board. The only thing that I have asked is that there be at least a minimum 30-minute retention. That's it. Other than that, if you want to use intermittent flow, continuous flow, if you want to use a hose bib as your criteria, if you wanted to use a sprinkler head going off in a park garage, all of these, yeah, they're all part of the process, but really what's the best way to design a sand oil? So that's just one. Another one might be, let's say a gas pipe system. I'll go back to that. How did you determine the sizing? Was it the longest length or the branch length? Without this information, it gets a little bit dicey to do a review because we, again, don't know what you know. And if you don't tell us how you designed your system, we can't effectively do a review. We're not there to revise your system, add to your system. We're only there to look at what other codes apply as well as what you've provided. One of the things that we look for quite often, and that is that we looked for sizing. And the reason for this is because it allows not only the detailer or the engineer of record or the professional engineer designing, it allows them to do the same thing that allows us to do when we're reviewing. And as an example, so we have many different type of loading, and I'll take a DWV system. Currently, what I would receive is a riser detail for each soil stack, and it would be maybe kitchens, bathtubs, and so on, or an entire bathroom group. And then at the base of that riser detail, the detail would just stop and not list the building drain, or if there were other subgrades where there was ejected sewer system. Typically what would occur when this was happening was I would have to do all the loading and then transfer that over to the underground and size the underground according to what load I pulled over from the riser detail. After I started asking and requiring that the loading be on a riser detail of a full componented system from vent through roof all the way down to maybe an ejector, what was discovered was that the discharging at the building drain, the loading not only changed in its drainage fixture unit count totals, but in a lot of instances, the actual pipe sizing changed. So this was a benefit not only to the designer, but to the installer. Whereas a system that is created as proposed without a review may have inadvertently got through the process and made it past the design professional, the detailer, the installer, the inspector, and maybe it could have been a backwater valve that would have been required, which is also part of the riser details. One thing about the riser details that I can't express enough is that Seattle has a lot of areas where backwater valves are required. And one thing that we do require on a set of plans is that we require the upstream manhole of the side sewer that the building drain is connected to, the elevation of that manhole. And we also require the first and second floor, finished floor elevation. And the purpose behind that, as part of the full DWV riser detail, is so that if there were a backwater valve that would be required, that backwater valve would be caught. When you break the system up and you just show just the riser detail and just a underground plan view, it's a little bit more difficult to recognize that unless an individual was actually in the field installing it and recognized it, or the plumbing inspector recognized it and saw that, oh, you need a backwater valve here, then it might be installed. Well, at that point, what kind of backwater valve? Normally open, normally closed? They both have a level of, based on how the plumbing system is separated, whether or not the cross-sectional area venting is going to be allowed. Anything upstream of that, of a normally open, is not. So it changes the venting. So this is why, in just one aspect, why we ask for a full riser detail, including all the components of that detail. It not only changes what happens in the field, because everybody's aware what's going on, but it also prevents things from being missed. This is also true for domestic water loads. from the meter all the way to the furthest fixture. And however you want to design your system, whether it's water supply fixture units or it's GPMs, whether you're using a prescriptive approach or you're using Appendix A or C, all of this is under the same umbrella as a DWV riser detail. One thing that has come up is subsoil drains. Recently, I received a letter from an email from Ed Holmes that talked about what Bruce Springer, who is the plumbing technical advisory at the Department of L&I, indicated that subsoil drains within the perimeter of a building is work to be done by licensed plumbers. Currently, we don't review this, and currently we're not really involved on that side or that approach of the system as far as what we review. We review from a detention or retention vault, and that being connected to the sanitary or the storm being ejected. We would look at something of that nature, but if it was within the perimeter of a building and there were subsoil drains going to sand, oil, we wouldn't look at that, and we don't review it. And I don't know where that's going to be in the future. I don't know if it's going to be elevated to a point where we would review it, but for current purposes right now, we do not review that. What other type of things that have to be on a set of plans? Well, it's easy to look at a set of plans if I know what either in-house abbreviations are being used or what type of system is being drawn based on the symbols. What we like to see on the cover page, which would be your first page under the general notes, would be schedules for abbreviations, those that are in-house, a legend, how many, where's my sheets at and how do they apply, general notes, and any symbols, definitely the index sheets, and so on. This gives us a good snapshot of what's in the building, how it might be designed based on what abbreviations are being used. Specifically, the general notes help us directly connect what code cycle we're in. As an example, here in the city of Seattle, on January 1st of 2017, the city of Seattle officially recognized the 2015 Uniform Plumbing Code. The state and the remaining building departments in the state of Washington recognized this on July 1st of 2016. So there was a 6-month difference in when this recognition occurred. Based on this recognition, what this basically means is that all the plans that were reviewed in 2017 at Public Health are most likely going to be under the 2012 Plumbing Code. And the reason behind this is because those structures that fell into a building permit under vesting ended up being vested under the 2012 Plumbing Code. So there are other criterion in the 2015 that is a little bit more restrictive in some areas and a little less restrictive in some areas that are forcing an individual to make a decision whether or not they're using a 2012 or 2015. But if you're going to submit a set of plans under general notes, it's very beneficial to us to know what code you're trying to apply to your plan set, whether it's the 2012 or the 2015. It does make a very big difference, especially on the insulating side. When you're using in-house abbreviations, please put those on your plans. They help out so much, and it's fine to have in-house abbreviations. You know, if you have a set standard or a way that you run your business, or design a system, as long as we know what they are, and they may be a little bit different than the norm, if we know what they are, it makes our job a little bit easier when we're reviewing your plans. And one thing I do want to make a mention of is that referencing subdivision 22 for all your plumbing needs under general notes, you can put that on your plan if you want to, but it's going to be basically ignored, not because it's what you've designed your project to, because that's where you're going with your project. You have contractual criterion that you have to observe, and that's part of it. But as far as our review goes, you can't reference something that we don't have or we can't see, which is subdivision 22, unless you're going to provide that in full, and then we're going to ask you to put it on some design sheets. It could get expensive over time, but if that's how you want to do it, that's fine. We'll go along with that process. We just need to know how you want to address what should be in your plan set that is part of the project. So when it comes to schedules on a set of plans, plumbing drain connections, what does that mean? Well, for every fixture in a plan set, there is a vent and there's a drain. We want to see that schedule for a couple different reasons. One, it tells us what fixtures are in the project. And it also alerts us to going through this process that, oh, there's this one different fixture they're calling a X, Y, or Z. And when we look at the riser details, we can go to the riser details and confirm that it's there. These onesies and twosies, they're missed quite often in a riser detail. And this not only alerts the designer and the detailer of this fixture, but it also allows the person who is reviewing it to know that this is part of the system. Sump pumps and sewage ejectors, another schedule, all the design criterion that would be involved with a sump pump or a sewage ejector. That includes the GPMs, the size, the venting, the vault, high-low cutoffs, what the DFU discharge would be at the point of connection. And this would only apply to not site built, but if it was a vault that was brought from outside, a manufactured vault, we would want to know what that is, just to confirm that whatever pressures might be being placed on it, let's just say that it's plastic and it's being subsoil buried, that we would want to confirm that it can withstand any pressures in maybe an area that is highly incorporated with water. So these hydraulic pressures don't collapse this tank. That's one place that we would ask for if you had sewage ejectors or a sump. We would want to know what that is. Other than that, if it's something that's being poured as a part of a mat slab, we don't need to see that. That's usually the engineer of records design that. You're just using his facility as a sump. Plumbing fixture connections. Again, going back to plumbing drain connection. Those two kind of tie together a little bit. The plumbing fixture connection, the purpose again behind this is to know that all of the fixtures are being accounted for and that they are being connected correctly. In some cases, we added this just for the purpose that in some places there are fixtures that should be indirectly connected, or that you would want to indirectly connect them for whatever reason. And we would want to know that criterion. Expansion tanks, this is another schedule that we'd like to see. Minimum operating, maximum pressures, temperatures. Purpose behind that is to confirm that the expansion tank being provided equals the system that it's being used for. The only way to confirm that that's so is that that type of information is on a plan in a schedule identifying the expansion tank. If there was anything that was out of balance with the expansion tank versus the system being proposed, that could be easily looked at, and that could be caught at either plan review or prior to plan review by the design professional. A fixture unit loading matrix, this is pretty critical. So what is a fixture unit loading matrix, and how does it work, and why do we need it? So a fixture unit loading matrix is a schedule that defines the plumbing fixture, water closet, lavatory, etc. Then determines the pipe size connection and the load of that fixture, hot or cold supply. In addition to that, in the same matrix, the schedule would also be the drainage fixture unit loads. 2 drainage fixture units, 1 drainage fixture unit based on the fixture. In addition to this load-in matrix, there would be a count of how many fixtures we are talking about. The count of the fixture is translated over to the pipe size required versus the water supply fixture unit demand and or the drainage fixture unit load. And the purpose behind having this matrix is twofold. The first one is that it identifies every fixture in the project. It tells me how many are there by the count, and then it gives me a complete loading. This can be used later in the rest of the schedules, specifically where we have booster pumps and so on, and we'll get into that in a moment. But it tells me the loading, how many water supply fixture units I need in order to make my system work adequately. Drainage fixture unit load, this tells me how to size my drainage fixture units. In addition to that, in this same matrix, the same schedule, I would be identified, or I would be told, is it a prescriptive approach using table 702.1 and 703.2 if it was DWV, or other tables in chapter 6 for water supply, or am I using appendix A for my water supply, and also am I using appendix C for my DWV sizing? All of this is in the fixture unit load matrix, and all of this tells me what your system is being designed to. So I can go directly to the information that is applicable only to your specific project, based on the fixtures that you're telling me you have, based on the loading that you have, and based on the location of the criterion for the formula or method that you're approaching your proposal of the system that you're designing. Hot water circulation pumps. If you go to the energy code, well, let me back up a little bit. So in the Washington State Energy Code, section C404, which is surface water heating, there's a few sections in there that specifically speak about hot water circulation systems, whether it's demand or direct. So this section for hot water circulating pump systems ties together with the Washington State Energy Code. And based on that criterion in the Washington State Energy Code, it is applicable to your hot water circulating pump schedule. So some of the systems that you'll find in there, how you return your circulating water versus the type of circulating system you're using or pump or not allowed to use, would all be in this schedule for circulating pumps. When it comes to water pressure reducing valves, the purpose behind asking for a PRV is that in some of these areas where we have pressure reducing valves based on the fact that we have to have booster pumps, we want to know the location, what you're using, where it's placed at, And we do that by looking at your water supply system riser detail. Piping material used. Sometimes we get a blanket that lists about every piping material that you can think of, but in reality, what we really want to know is what's just applicable to your set of plans. Are you using PEX pipe? Are you using copper? Are you using DWV for cast iron? Or are you using plastic? If it's just applicable to your project, that would be nice to know, and not list, as a boilerplate, 20, 30 different types of systems, unless they are applicable, and they could be. Electric water heaters, we'd like a schedule for electric water heaters. With electric water heaters, it doesn't apply here, but on-demand electric water heaters have first hourly ratings, and there are formulas to make the crossover as opposed to a storage tank type. And if you are interested or would like to know how to get that information, one individual to contact is Luke Howard with the Washington State Energy Program, who has some pretty good information on how to make that crossover, an on-demand electric versus a storage type water heater. Anyway, that electric water heater schedule is one that we look for. It tells us what you're doing and how you're using your water heater, especially if in the notes or remarks where you're stating that, oh, this is a 12 or 20 gallon water heater and it's going to be above a floor ceiling assembly in a restroom and it's going just for the lav. What this would tell me is that, okay, there's a stand up there somewhere and it has to be a listed or labeled stand. If you decide that you're going to design your own type of equipment up there, whether it be a platform of some type, then it would have to be done under the rules of Chapter 16 of the International Building Code, which is seismically restrained. Natural gas water heaters, of course, we want to know that in a schedule. We'd like to see that in a schedule. Why? Well, we want to know where your combustion air is going and how you're getting combustion air to it. Is the gas pipe sizing going to be adequate based on the BTUs? Is it over 200,000, and should the state look at it and not the local public health plan review program? The divider is 160 PSI for an unfired pressure vessel. That would be anything greater than 160 would be a state. Anything greater than 200,000 BTUs for a water heater system would be, or a boiler type, would be the state. Water booster pumps. We want to know that information because this is going to directly correlate and connect with your pressure loss schedule. Your pressure loss schedule is going to give us all the information that we would look at, and in the course of that information in a pressure loss schedule, if there was inadequate supply, then a booster pump, a water booster pumper would be necessary. And if that's the case, then we want to know all the criterion behind that booster pump. Same thing with storage tanks. Storage tanks can be used at different levels. They can be used at for closed systems, like maybe a solar heating type of system. We want to know that storage tank. We want to know how that it's being connected or not connected, whether it has makeup or other type of uses of water. Storage tanks used in conjunction with on-demand, we'd want to know that too. Of course, we'd be able to go back to the circulating pump schedule to figure out what type of system you're using, whether it's a demand or other. When it comes to ADA schedules, we're not really looking for a breakout or break apart ADA schedule, other than the fact that when you have your plumbing fixture schedule, that you at least mention that I have this type of a water closet and it is ADA, and then list the requirements that here's why it's ADA. It's a Moen type of faucet, etc., and so on. As I stated earlier, concrete vaulted designs that are precast structure only, this is what we would review. If it was something poured into a slab, we wouldn't review that. That would be the engineer of record. When it comes to interceptors, we do want to have an interceptor schedule as a breakout, whether it's a sand or oil or a sand oil, a grease, or a flammable liquid type of interceptor. The purpose behind all of this is one, that we want to see how you derived at the sizing of your interceptor. And the purpose behind that is to confirm that what you're proposing is not something that you've used previously that was approved or that was inspected and approved, but that you're actually designing something to the proposed system and the use of the location that it's at and the use of the system that's being discharged into that receptor. Knowing all of that information, that allows us to better understand what your system is doing. Backflow devices. This schedule right here is kind of twofold for us. When it comes to backflows in this schedule, we'd like to know where you have these backflows. Irrigation, makeup water, potable water, or other uses of a backflow device. And the purpose behind that, again, is so that if there need to be one in a set of plans, that somebody doesn't overlook it. As an installer, it's easy to put a system together and several people may miss it, including the inspector, including the installer. It's just as easy to put the location of where this backflow device is to be on the water supply pipe riser diagram, and then include it in a backflow device schedule. And in that schedule, one of the criterion for the schedule is the location of it. Where is it found at? It's found on sheet A, B, P5, whatever. And in that schedule, it tells me what it's used for. Well, is it the correct backflow device? Does it have to be an RPBA? Can it be just a DCVA? And so on. So this also, once again, helps not only the person designing the system understand that maybe they're going a little bit overkill, but maybe they want to. Maybe they want an RPBA and not a DCVA. Or maybe they suggested a DCVA, but it really should be an RPBA. So in this schedule, we look pretty heavy and hard at that schedule to confirm whether or not that schedule is adequately providing the right or enough information for us to make a review of whether or not the right device is used. When it comes to mixing valves, again, this would be on a breakaway schedule, and the purpose behind that is that it's not regular shower valves, it's not other types of diverters, it's the diverter being used for the system itself. Is it designed for the system? Can it carry the temperatures? And in the construction detail that we'll talk about later, this type of mixing valve would be shown in that construction detail. And at that point, then I would be able to look at it and say, oh, they have a direct hot water circulating system, or they have a demand circulating system, and then all the other things that are supposed to be applied start to fall in place, especially that which is part of the Energy Code C404. Gas pressure regulators. When we look at gas pressure regulators, yes, we want a schedule. Why do we want a schedule? Because not every appliance that is installed is a direct vent, meaning that it has a supply of air and exhaust that are communicating with the outside through a dedicated piping system. In some of these instances, they are actually gravity vents. And what you'll find is the gas pressure regulators, in some of them, will give you a specific allowance of distance to be from a vented gravity vent of a gas fixture. I think it's somewhere around 6 feet, but when you fill out the gas pressure regulator for a medium pressure, there you will list whether it's vented or vent limiting. And that tells me another story. If I was to look at your gas medium pressure regulator schedule and I saw that it was vent limiting, it kind of triggers in my head that, okay, most likely this is direct vent, but keep it in the back of your mind, it could be a gravity vent. And then distances start to play. Gas appliance fixtures, of course we want to know that. If I don't know what you're installing and how many BTUs the fixtures are, there's no way that I can adequately go back to your gas pipe size and riser detail and start to plug in information and do a quick review to see if it's sized correctly. Plumbing fixtures, again, as I stated earlier, every plumbing fixture that's on that project should be in your plumbing fixture schedule. The purpose behind that, of course, is to connect that to your plumbing connection schedule that says how big your pipe has to be versus your water supply fixture matrix, telling me how many fixture units you have out there and if any fixtures are missing based on the count or the actual plumbing fixtures itself. That all ties together. It makes it so that a review can happen, but when some of these schedules are missing, it leaves it up to the person to either do longhand and count it out, or another method, which is call up the design professional or start the email chain of requests. That's time consuming and it's really not necessary if all the information is in the schedules. I spoke earlier about domestic water service and pressure loss matrix. This is where we talked about earlier about the booster pump schedule, backflow devices, pressure reducing valve. They all tie to this domestic water service. It helps me paint a picture of what's being designed. If I know your if I know your static pressure and I know all your losses to your system design and all your friction for piping, I can better understand where you're at in your system based on I'm going to supply a booster pump because I am negative pressure, etc. That helps me determine your system with you, but it doesn't help me size your system because that's not what I do. All I do is just, I'm a filter, an extra set of eyes, basically is what I am. Insulation, Washington State Energy Code, I spoke of this earlier. The benefit to the 2012 versus 2015 is pretty rough. Currently, Dwayne Johnlin, who has expressed that they are working to discover more information in research based on the requirement that all hot water pipe be insulated. That means in areas that is conditioned space and areas that are unconditioned space. That means all hot water piping. This could be a huge blow to somebody who, on the flip of a dime, could get word anytime saying, we're going to require this. We don't have control over that. That's the city of Seattle. We have worked with them and they have informed us that yeah, they're going to do the research and confirm that whether or not this is a benefit or kind of overreaching maybe with a code. Sometimes that happens. There are unanticipated consequences of creating a code. It affects other areas of a code that are not only costly, but they really don't, in the spirit of the code, promote the code itself. In this case, it would be energy conservation. But if you insulated all the hot water pipe, what are you really conserving? How much are you conserving? Is the code worth having versus the energy that you're saving, and so on? So we haven't heard word back from them recently, but I'm sure they're going to come in contact with us sooner or later and want another roundtable discussion about where we're at and how we're going to address it. To best of my knowledge, other jurisdictions aren't enforcing that yet, and I think it's probably because there's a little bit of a determination that it has value, but maybe not as much as it as it appears to be. Of course, circulating systems we insulate, right? When it comes to the gas code, I just want to kind of get this out there, and I'm going to read from the slide so that those of you who are listening can hear what the slide has to say as I've put this information on our website. It says, the City of Seattle and unincorporated King County do not use Chapter 12 of the Uniform Plumbing Code to regulate natural gas pipe systems. The City of Seattle and unincorporated King County use the 2015 International Fuel Gas Code for commercial projects and the 2015 International Residential Code, Chapter 24, which is a full excerpt of the 2015 International Fuel Gas Code for residential projects. The only exceptions are in the 2015 International Fuel Gas Code, whereby Washington State Amendment, liquefied petroleum gas is regulated by the National Fire Protection Association, NFPA 58, which is LPG storage, handling, and transportation, and the NFPA 54, which is LPG installation. Installing gas pipe systems within the City of Seattle limits require a City of Seattle gas pipe license. This is Seattle Municipal Code 6.430. So after saying all of this, I still get plans that are stating Chapter 12 of the Uniform Plumbing Code. After this has been on our site for 9 months, and there is a general understanding that this is where gas pipe systems are actually created from. This is the code criterion. Well, the Seattle Gas Code, which is basically the International Fuel Gas Code in full, is the process that you would use to size and design your fuel gas code, your fuel gas system, with exception if you have hybrid systems that are of like a CSST system. For those of you who do not know, that if you do have a CSST system, a lot of the requirements out of the International Fuel Gas Code and the Seattle Fuel Gas Code apply, but the sizing does not. To do this, you have to actually go to the manufacturer of that CSST system and size your system. They have different breakouts, and they only apply the branch length method. In addition to that, as a side note, you might see that they'll call it the longest length, but it is really the branch length. And that's specific to flash shield. Construction details. So we ask that construction details be quarter scale and that they show connections of specific fixtures or equipment. And as I stated earlier, there's a lot to be said about the schedules that are provided and the construction details, and do they match? So one of the schedules that we ask for as a construction detail are the water heater installations. Why would we ask for something like this? We have multiple stories that are 6, 10, 12, 14 stories. And in some instances, I've had water heaters that may have been on the first or parking level where they were trying to send the exhaust from a water heater all the way through the project out the roof. That's correct, that you need to get the exhaust out of the building. The only caveat to that was that it wasn't allowed to go that far. The exhaust was only allowed to go up to, like, I think 104 feet, but they had it somewhere around 100 and, I don't know, 40 or 50 feet. So there's limitations, and these construction details help make us aware of what type of system you have. Let's go back to a statement that I made earlier. Direct vent versus gravity vent. If I know it's a gravity vent and I look at your medium pressure gas regulator schedule and you say that you are using all vent limiting devices, then I can make a note on the plan saying, okay, then if you're going to use vent limiting medium pressure gas regulators, then keep them the required distance apart from the vent collar. etc. So these are things that they kind of are on the cusp of code requirements, but when you're doing plan review, they also come into play. And when you look at the health of a system, if other people miss it and I don't mention it, then it's just missed. Also, cast in place concrete vaults. We talked about this earlier, and I stated that, you know, if it was a mat slab and there was a storm retention detention vault or a type of a manhole or even a vault or sump, then that would be all part of the engineer of records review. We don't review that, and you wouldn't have to have that on your plan set other than to show that your ejectors are encased in something. Medium pressure gas regulators, we were just talking about this. This seems to be like an ongoing issue that those that go around and troubleshoot gas-fired appliances have told me on many occasions that what needs to be done after they confirm that the equipment is operating fine and that they haven't missed something, that their second avenue is the regulator. And in some instances, the requirement for testing a regulator has not been kind of a common knowledge thing, or it hasn't been provided for those who service these gas appliances and this type of equipment, which makes their job, one, easier, but it also allows them this availability to quickly go and diagnose the system. If they find out or know through their own experience that the equipment is behaving properly, then the only thing that it could be having a problem with is the supply. So a medium pressure gas regulator construction detail at quarter scale that shows the test ports in accordance with the International Fuel Gas Code or Seattle Fuel Gas Code, section 410.2, items 4, 5, 6, and 7, which basically say that when I have a medium pressure gas regulator and I'm dropping down to low pressure, I need to have some sort of a test port, one prior to the regulator and one after the regulator. The test port prior to the regulator could be, and it should be, relatively close to the regulator. The downstream test port cannot be closer than 10 times the pipe size that is connected to the regulator. And then on either side of the regulator, there should be a union within a foot. Now, this benefits those that are troubleshooting a system to quickly diagnose whether it's the equipment or the regulator. And if it's the regulator, I think as a public health risk, we want to get to that as quickly as possible and not prevent a system to continue to malfunction while a individual is trying to correct an issue with the gas-fired appliance. When it comes to sump pump connections, we want to see the detail in full. We want to see the vault size, the depth. We want to see your sump pumps, whether or not they're explosion proof or not, the venting, the discharge pipe, the type of piping material that's being discharged, and all of the bell and whistles that you would normally see from either audible, supervisory, etc., high, low cutoff, that would define your system and how you're ejecting effluent. Trash chutes, I think we talked about this a little bit earlier, where you have backflow devices. Those that are used in a trash chute, RPBA, although this detail is rarely seen on a set of plans, we ask for it. And the reason behind that is not every trash chute is using cold water. Some use hot water, and some use really hot water, not just 140 degrees, but hotter. So not all backflow devices are rated for super hot water. And if you're going to use super hot water, then I would need to know that the type of backflow device that you're using. Roof drains, we want to see a detail for roof drains and how you're connecting them. If you're doing a two-part system where you have a primary going to the storm utility and you have the secondary going to daylight at the structure somewhere where it can be seen, having a construction detail lets us know that you have designed a system for 1 hour rainfall. If you provide us a roof drain detail where you're tying the primary and the secondary together, that tells us that your storm riser detail is being designed to 2 hour rainfall per hour. So it just gives us a quick synopsis of what your system should be designed to based on a construction detail. Suds relief. We ask that there be a detail for suds relief. This seems to be like almost a kind of like the medium pressure gas regulator. It seems to be an always calming review comment that as a plumbing inspector, when going to the field, this is a correction that is written quite often, suds relief. The assumption is that in some groups that what's occurring with suds relief is that the suds are discharging out the receptor that is receiving a suds producing fixture, whether it be a clothes washer, a dishwasher, kitchen sink, and so on, that's what the issue is. Well, that is not the issue. The issue is that obviously air in suds, soap, connected together create a block to the venting system because these suds are heavier than air and prevent the air from moving in the system. That's the purpose for the suds relief. Just as a side note, I think, and I can't remember for sure, but the original concept of the suds relief was that 8 feet is what we use today, but the original concept, I believe, was 40 feet. So it's been shrunk down quite a bit. And I can't remember where I heard that from, but I'll research that. Dog runs. Dog runs cannot go to the storm. They must go to sanitary. About 7 months ago, maybe 8 months ago, there was a team who investigated the outfall of a storm pipe that had fecal matter in it, and they traced that all the way back up to a dog run. At that point, there was a switch that all dog runs must be discharged to the sanitary, and all systems that are in current retroactively must be reversed and changed from storm to sewer discharge. In addition to that, there was a limitation. There was a limitation that allowed only 200 square feet for a dog run, but that limitation is not there any longer. You can have an area greater than 200 square feet. You just need to contact the City of Seattle, and I will make sure that Bailey gets that email address. And it has a lot to do with whether it's a covered or uncovered area and how you're using the dog run. So it's really out of my review process as to the sizing of a dog run, but I do know that it can be much larger than 200 square feet. And of course, we need a construction detail for that. And I also have a detail that I can provide Bailey with for a dog run that gives you some options as to whether or not you would need to have a secondary for overflow as opposed to just a primary. Keep in mind that, this is an uncovered area on top of a roof in some cases, but in all cases, obviously open to atmosphere. So the larger the area, obviously it acts more like a roof drain rather than a primary receptor, which would be a floor drain. Parking garage, auto wash. Yeah, we want to see that. If you have something like that in your project and there's going to be bicycles that are being taken to a specific area for washdown, where there's also vehicle washdown. We want to see that detail in full. What kind of water you're using, what kind of chemicals you're using to wash with, degreasers and so on, where you're discharging it to, and how did you get to the size of the receptor based on your formula or your method. That would all have to be part of a construction detail. And complex mechanical systems. We would want a construction detail for a complex mechanical system. Oh, what's a complex system? Okay, this would be a complex system. I have a 4-inch water service line coming into the building where there's a 20,000 gallon sewage tank with the 4-inch running through it, taking latent heat, going to heat exchangers, going to heat pumps, and then from there going to reverse cycle chillers. That's a complex mechanical system. I would want to see a detail on that. And that system that I just mentioned is one that we did review. So kind of moving forward from the schedules and the construction details that we would like to see on a set of plans that are beneficial not only to us, but are also beneficial to the installer and the designer. There are systems that are outside of prescriptive and that are outside of the appendices in the plumbing code. So here we look at the different types of appendices that can apply. And we have Appendix A, we have B and I, those are adopted, but Appendix C is not, Appendix L is not, going back a code cycle for other types of systems. And what we've discovered is that if we have a way for somebody to submit an alternate engineered design or an alternate system itself through a submittal process, which would include an alternate material method or modification request form, this would allow those who want to go beyond prescriptive, go beyond an alternate engineered design and leap into sustainability. These systems are very complex and they require a lot of attention. And the way that we work the process is that if you submit an alternate method modification request form with the process that you would like to propose, that would be the process to go through. Not any other process. And the reason for that is because site-specific, job-specific, system-specific. Just because one type of alternate engineered design system based on a manufacturer's product will work in just about the structures or a lot of structures, it doesn't mean that that gets carried from one structure to another as the system kind of on a carte blanche, okay. Each time that you design a system that is an alternate engineered design system, it requires an alternate alternate material method or modification request form. And the types of systems that we're talking about is if you wanted to use more than 4 branch intervals for AAVs. This is a policy that was in play all the way back to 2008. It's Public Health Seattle King County decision number 04-006. It was created and implemented July 18th of 2008. You will find that in this decision that more additional allowances are made through the type of AAV and the manufacturer of that AAV can be applied. However, this would require an alternate method modification request form for the purpose that we only allow it to go up to 4 branch intervals. Manufacturers allow it to go more. But we want to see the system that you're placing it in. Is it something that is communicable to health disease that would cause or promote a health issue? Let's just say it's a research laboratory. Finding out that an AAV, let's say because it's a mechanical device, failed when you have such chemicals or vaccines that you're using in a laboratory is the wrong time to find out. So would we allow something like this to be used where it has a possibility or potential to fail? It depends on what's being used. That's why this would require an alternate material method or modification request form. Another system would be a PAPA system, which is also known as a positive air pressure attenuator system. This is a design system that uses transients, negative and positive, through the use of mechanical devices, also known as a single step pressure system. It was designed by Studer with the IPS Corporation, and we have approved them in the past. And we had currently asked that at one point, a third-party review be provided for one of the plumbing contractors who submitted this design, and it came back that the third-party review saw that there was no issues with this system and that it was a viable plumbing system. Again, would we allow something like this in a UW research facility? It's questionable only because mechanical devices fail. Single stack waste and vent system, that would require a alternate material method or modification request form. So would DWV vacuum systems. These are all types of systems that are outside of the normal systems of plumbing that you'd find in the prescriptive code or that you'd find in an appendix. So are gray water systems. When it comes to gray water, we get kind of it's not really a problem, but it is an issue to get around. So in 2011, the state came out with some gray water criterion, and they had tier 1, 2, and 3. Tier 1 basically applies to single family homes, 2 and 3, more usage and more commercial. But during this time between 2011 and 2014, there was an allowance made to the programs, specifically the on-site programs, to create a gray water ordinance or policy. Public Health Seattle King County did not do that. So we can approve gray water systems, but the system that you're obligated to design under and the criterion that would be involved would be in the Washington State Administrative Code 246-274, specific to gray water systems, tier 1, 2, or 3. There's a lot of design criteria in here. If this is an approach that, as we move into the future of sustainability, in which we're all for that. If there's a way that you can conserve, we would help to partner with you and be a part of that process, whether it's energy, water, etc. Non-potable rainwater harvesting systems. This would require you to have an alternate material method or modification request form. One thing that is not made aware of, if you read fully through all of the criterion in Chapter 16 of the Uniform Plumbing Code of the 2015, what you'll find is that every 4 years, there's a requirement to do a cross-connection test. So as I stated earlier, if you had a multi-story structure and you had many tenants in a building, let's just say you had 10 a floor and you had 5 floors, you would have to inform everybody that they would not have no water facilities until the cross-connection test was done. What is a cross-connection test? We shut off the non-potable and we charge the potable, and we go and test every fixture. We shut off the potable, charge the non-potable, and go around and test every fixture. That's very time consuming. Energy, let me see. Alternate energy sources like solar heating or types of heat exchange. These types of systems also require an alternate material method or modification request form. As we move into different closed systems using heat exchangers, whether they're single wall, double wall versus the medium type inside of those closed systems, is also determining or driving this requirement for alternate material method or modification request form. We would need to know that so that we're connecting or have a potential connection from a non-potable to a potable system. Appendices that are not adopted by Public Health Seattle King County. Those would be can you go back one slide? Appendices not adopted by, oh yes, the appendices obviously in the plumbing code. If you go to the Seattle Plumbing Code, you won't even find Appendix C on their website. But you will find it in the Uniform Plumbing Code and applicable within the unincorporated King County, who uses the 2015. But do we allow Appendix C to be used in the city of Seattle? Absolutely. Just to refresh a little bit on the riser diagram details and the different systems, here's some things that in the development standards that we were working on. Before we go any bit further, I just want to mention that these development standards, each one of them has a little bit of a tweak to what you're accustomed to. So the gas pipe system, currently everything is in sizing based on the International Fuel Gas Code or the Seattle Fuel Gas Code. And it's typically off of 1,000 cubic feet BTU, right, per foot. PSE allows 1,100. So that means smaller pipe, right? Smaller gas pipe. But what if we had a diversity factor incorporated into that system and allowed us to use the full code, length, sizing, pressure loss, water column, and diversity? If we had that diversity factor, what would that do to our system? It would allow us to put in systems that were really more in line with the probability of use. What does that mean, Steve, probability of use? I have a gas pipe system. I have a kitchen stove, it's gas, and I have a barbecue, it's gas. Am I going to be cooking on both at the same time? The odds are just about no, unless it's maybe Thanksgiving or Christmas or something like that, or a big get together. But would that apply to a 200 unit apartment complex? Is everybody going to be doing that? The answer is no, again. So the diversity factors allow you to take a certain amount of fixtures that would most likely be used based on the probability of use, thereby reducing the size of your system. This is one of the things that we tasked Rushing Engineering with coming up with. Get to a diversity factor. We'd like to see that. Water supply pipe systems, McDonnell-Miller, 2018 UPC will have an allowance in the appendices to use 3/8 to your plumbing fixtures. You say, well, Steve, we already have that in the Appendix A. This is true, but we're now trying to shift gears and make it where if you were to look at the sizing of water supply in Chapter 6 in our requirements for fixtures, the minimum is 1/2 inch. We're going to try to turn that upside down and make it 3/8. So that's one of the things that McDonnell-Miller is tasked with, finding a way to take the 2018 UPC appendice and make that the driver for sizing water supply systems, reducing the amount of pipe that is needed. Why would you want to do that? Well, as we continue to reduce the heating requirements of a water heater and dropping down from 140 to 120 and so on, Legionella is an issue. And it's kind of underscored, and right now I think it's pretty much an open comment that Legionella has risen dramatically since the reduction of the water heater allowances for a maximum of 120 or 110, whatever it may be. This is a breeding ground for Legionella. And the wet wall of a larger water pipe sometimes doesn't get scoured. A recent study where they showed a glass pipe with a 4-inch water main and dye interjected into that water pipe showed the dye going right down the middle of the pipe and the outside of the pipe not even being affected. This is oversizing. This is helping promote Legionella, and we're trying to prevent it. One way to do that is to get the water pipe sizing down to the actual energy conservation use of the fixture itself, right? 2 gallons per minute showers and so on, right? But we can't go too low on some of those fixtures, right? The different criterion for allowing ASHRAE 1016s and so on, they have limitations that you can go within reducing the amount of GPMs before that allowance for the ASHRAE doesn't work, okay? But as far as going back to wet walls and scrubbing the walls, that's one thing McDonnell Miller's been charged with, was to get us to the 2018 Appendix C and get that pipe sizing down small enough to where this becomes less of an issue in the future. So plumbing plan review fees are assessed on a project-by-project basis and can take up to 4 weeks for the first review comments. This seems to be holding true. We're at one time, we were actually about 5.5, almost 6 weeks out, and we worked very hard to get that down to 4 weeks, and we're still at 4 weeks. So there was a brief period there where there was maybe a 2-month window or less where we were at 6 weeks, but we've stayed pretty consistent at 4 weeks for review. And that does make a big difference when you're trying to get a lead in or a lead time for a project. You want to know how long this is going to take me and how long my review process will be. In addition to that, how do I submit a set of plans? If I know I'm going to be 4 weeks away, how do I get my plans to you? Well, currently, we are not reviewing electronic plan review. We are reviewing only paper plans. This may be something that will happen in the future, but again, if the industry pushes us and pushes public health, specifically environmental health services, there's a high probability that if the demand is that we don't want to submit paper plans and we want to do electronic plan review, I would highly go along with that, and it would be nice to have that happen. So currently we ask for 1 set of paper plumbing plans with a check in the amount of $201. That $201 applies to the first hour of review, in addition to the administrative part of the intake process and the approval and release of the plans. During the plan review, the process is that for every 1 hour of review, a fee in the amount of $201 is applied. So on average, the fees have been somewhere around $800 plus or minus $200 or $400 based on how well the plans were submitted. If there's, like I stated earlier, many schedules missing, incomplete riser details, no construction details, missing information, misinformation, it can cost you not only monetary time or monetary amounts for us to review and re-review, but time. It can really mess with your schedule. And I know, working in the past as a project manager, that having a delay in your schedule is compounding, and it's unsettling to have an unknown factor. as to how long it's going to take to get something done, where we're all driven to be productive. That's what we do in this industry. We are productive. And when we have an unknown, it doesn't help us with our planning. So I hope that we could in the future have electronic plan review. And this would be a great way to segue to a cursory review as well that says your plans are lacking this or that, without having to actually meet in person or be on the phone and try to discuss something we can't both see. This would be a great way to, once again, segue for electronic plan review if that's what the design community wanted. As far as fees are concerned, as I stated, the $201 fee is the cost that it takes per hour until the plan is reviewed and approved. There have been very few plans that have made it through the process in one review without a review fee or a resubmittal. I can think of only maybe 3. One of the biggest ongoing review comments is on the stormwater systems. Consistently sized incorrectly, even from a prescriptive approach, even if they're using GPMs or they're using square footages, which evaluate or transfer over to GPMs, it doesn't matter. It seems to me like this is the biggest issue of all of the reviews that I do. It's the most corrections that come up, and there's always a comment for the stormwater system. When it comes to a fee-based system, currently right now we do not have a fee-based structure for plan review. It's hourly, and what's nice about an hourly review is that the overachievers who submit solid criteria, good designs, lots of information, this allows me to go through a set of plan in a review very quickly. So the hourly fee is very beneficial to them, for those that are overachievers in designing and submitting. They want more than what's asked for. Having a project as a percentage of work value, that's something that right now we're not doing. And the purpose behind that is because we just are not that comfortable or familiar with how that process could be used to adequately have the reviews mirror a project. And if there's some suggestions out there, we're open to them. If somebody would like to transition from a hourly fee review to a percentage of work review, just remember too that as we progress into the plumbing plan review process, we started out with 3 stories and greater, but we hope to encompass much more than that. We hope to look at just about everything that has plumbing in it, if it's possible. That's future, way down the road. One of the things that not mentioned in any of this information that I was talking about was a building code study. And a building code study is that information which is on a set of architectural sheets, usually the first or second page of a design concept of a structure. And it houses all the square footages of the rooms in the structure based on the occupancy of that room. This information is then used to show the minimum plumbing fixtures required in a specific project. So Chapter 29 of the International Building Code is where this information is found. How many men and women toilet or lavs are required? And that information is specifically derived from the architectural's assessment of how many square feet are of each type of assembly, whether it's a business, an assembly, a mercantile, and so on. These square footage amounts tell us how many occupiable restrooms are required of the minimum amount. Lavatories, toilets. It used to have mop sinks, but they've taken that out. And it also has drinking fountains. Now, you might say, well, that's really not the plumbing code, Steve. That's the building code. And you're right. It is in the building code. But how often have we seen establishments where there's a men and women restroom and the women line is 2 or 3 times longer than the men? The purpose behind this inequality was that at one time there was a 50-50 split in plumbing fixtures for minimum requirements. This no longer exists, this disparity. It's more applicable to what is actually happening as opposed to even split of fixtures. And when I review a set of plans and working previously as a building inspector and a building plans examiner, I can look at a set of plans and kind of say to myself, it does or it does not have enough minimum plumbing fixtures. In addition to that, when you hit a certain amount of plumbing fixtures, a sum total, meaning a sum of 6, other things start to happen. We have to have accessible toilet compartments. We have to have ambulatory compartments. We have to have family assist restrooms. What's that got to do with plumbing? Any plumbing system that is designed for its full intent, its purpose, and its use. And in this case, if a system is designed and it's not approachable and applicable to everybody, then it's not a full system design. It's not in its complete design. As an example, you may have a stadium with hundreds of people that are attending, and to have some sort of equality of the use of those restrooms, there has to be a way to determine how many minimum plumbing fixtures are going to be used. And that includes, as I stated, wheelchair accessible, ambulatory accessible, and family assist. And it is all driven by the occupant loading. And that occupant loading can only be derived from one location. That is the architectural sheets. It's typically the first or second or third page. And in there is all the design criteria for minimum plumbing fixtures. This will be one of the things that we will drive forward with and require that they be on a set of plans. And the purpose behind that, again, as I state, there has to be equality. Gender neutral restrooms, multi-stall. I've had lots of questions about these. We were all familiar in the past with the unisex restrooms, which typically were in a small dining restaurant and it just said unisex on the door, male or female occupant. Now we have, by city ordinance, City of Seattle, but not unincorporated King County, but only the City of Seattle, that you can have a gender neutral restroom that has a whole different set of criterion to it. In these type of restrooms, there are multi-stalls and can be used by multi-individuals, and everybody shares the restroom, male and female. There are quite a few of them that are in use right now, and you can go to, I believe it is the Seattle Civil Rights Office. I believe they actually have a list of where those are at. When you submit a set of plans on our website, We have different times. I see that one of the slides is incorrectly labeled, and I'm going to try to get this changed. It actually says that we are open from on Tuesdays from 9 to 4 p.m. That should actually say Thursdays, and I will get that changed. So those of you who want to submit a set of plans, do not make a dry run down to our department.
We want to take a quick 5-minute break. We've talked for a while and come back, finish up with the Q&A.
Yeah.
Do you want to do that, or do we want to?
How many slides are left? I think there's only like 2 or 3.
Okay. Do we want to finish that? Okay. Go ahead.
Okay, so there's 2 locations. There's the Chinook building over at 501 Fifth Avenue, and then there's the Southeast Eastgate Way office, which is located over off of Eastgate Way in Bellevue. Oh, we covered that. Okay, I think I already covered this about the Seattle Municipal Code 6.430 for gas piping. When I see a set of plans that come in, I've been asking that if you're going to have your gas pipe welded, then I need some sort of criterion on your plans, what you expect to see as a minimum. And when I say that, I don't mean that you're to design the entire system. It's kind of like, as a minimum, do not have less than this type of weld criterion, this bevel, this rod, etc. And the purpose behind that is that if we leave too much information to the field to construct something, then it may not be what was originally intended or proposed. You may end up with a less of a system or inferior weld than you would have expected had you listed the criterion of what the minimum should be of that weld. So plan reviews that are not covered under my authority to review, currently right now, commercial kitchens, with exception of grease interceptors. The reason I state grease interceptors is because grease interceptors have a listing that they've been tested to an elevation of only 13 feet. In other words, from the highest grease producing fixture, which may be a triple sink, 3/4 full, to the invert of a grease interceptor, this is the elevation that the grease interceptor is listed to as a listed product. When they exceed this elevation, whether or not it exceeds the usability of the actual grease interceptor can only be determined by the manufacturer. I've had these grease interceptors 20, 30, 40, 50, 60, 70 feet different in elevation, and usually when there's a proposed design provided to me, and my review comment is to go see the manufacturer and have their lead engineer take a look at this design, the design changes dramatically. So there is a great deal of emphasis on this, and that also there would be a test port downstream of this grease interceptor. And I believe that probably most likely in the future that Gary Christensen, the supervisor of the FOG program, will probably start a process to actually look at these sample ports to confirm that whatever is being discharged into the system is under whatever criterion that they in the future propose be met. Backflow devices outside of a structure, that is Seattle Public Utilities, Bob Eastwood, Bob Hubbard. And foundation drains to the detention vault. We don't review this. I talked about this a little bit earlier. I don't know where it's at today, but we don't review it. Building sewers, we stop 2 feet outside of the building, and that's the end of our review. Fire stop, it's not under our authority. That's out of the building code. It's not part of the plumbing code. And when it comes to plan sizes, We did ask for, or we did at one point make an allowance for 8th scale, but what was happening was we were getting plans that were at 8th scale, but we would have 1, 2, 3, 4, 5 different systems on one plan sheet. I couldn't see what was on the plans, let alone track the system. It crossed and meandered amongst itself so many times that it looked great singularly, but as the layers were applied to one sheet, it just became convoluted. So we changed the criterion from allowing an 8th scale to requiring a minimum quarter scale with a minimum size of architectural sheets of 30 by 42 type E sheets. And I say the reason we did this is because, again, I don't have a problem with having multiple systems on one sheet, but if you have so many systems on one sheet that I can't track it, that means that whoever's looking at that in the field is doing the same thing I'm doing, wondering where the pipe went to, and is there anything else that I missed? And of course, you can't read anything below it because it's all covered with pipe and all sorts of abbreviations and symbols and some nomenclature. So that's the purpose behind the quarter scale. And I think that's it. That's it for the minimum requirements for plumbing plan submittal. So I think we're going to take a 5-minute break, and then after that we'll do Q&A. Good? Okay. Can I shut this off? I hope I covered as much as I possibly could remember, and if I didn't, this is what this time we can use for. Are there any questions? Yes?
Are there any schedule templates in production or that we can see to see what you require, like the information that you require in the schedules?
That is a really good question. So currently right now, as I mentioned earlier, the 4 engineering groups, McKinstry, McDonald, Miller, Russian, and AI, who are in process of these development standards, are connecting and creating schedules that will have information housing inside of that schedule similar to what I have spoken, but in a more robust way that is more connected to the design of the proposed system. Those schedules will be not templates that you can pull away and use, but templates that would house the criterion that would need to be in a schedule in order for that schedule to adequately represent the system that you're designing and also show what should be in that schedule that is representative of the system that you're designing. Did that answer your question? Yeah, okay, yeah, those schedules, they're coming out. We're working on the format right now. We gotta design something that won't crash our system, but they're being worked on. So that's a good segue into how our format would look. The format would look kind of like this. There would be 3 columns. The first column would house all of the schedules specific to a system. And let's just say that we're talking about stormwater. The first column would identify all of the different type of schedules that would be involved in a storm system. Material, drains, hangers, and so on. In the middle column would be the ways to design that would be inclusive of a complete system and all the criteria that would need to be shown on the plans, such as here's my primary, my secondary, here's my rainfall amount, here's where I'm getting my information from, and here's my sizing. The third column would represent applicable code sections, formula and equation. This ties all 3 entities together. how you size your system based on the formula or equation, and also the applicable code sections that would apply to your system, and then the schedule in the first column identifying how that information should be on a set of plans. This would reoccur for all 4 different systems: water, DWV, and gas pipe systems. Same format would occur, just exactly as I've spoken.
I think there was one online. Carmen, do you want to read it out?
Sure. The question comes from Amanda Moore. She's asking from one of her engineers, are we required to take the sprinkler blow down drain to an oil water separator? If so, this also require us to have a 30-minute retention time. And then part 2, a second question is, can you repeat the information you mentioned about the dog run overflow drain, and if that has to go to the storm system or not?
Okay, well, we'll go in reverse order because the first question is a little more complicated. Now, the dog runs are required to go to the sanitary sewer, all dog run receptors. I will see to it that Bailey gets some information whom to contact over at SDCI that will take your information about other components of a dog run system being a size greater than 200 square feet, covered, uncovered, etc., and options for secondary relief that like a storm drain system, because most of these are in uncovered areas. The first question that you had was, does a fire sprinkler blowdown, which is either an annual test or yearly test, discharging to a hub drain, have to discharge through a sand oil interceptor? Well, first I'll talk about what codes apply. So section 1018 of the Seattle Plumbing Code, in which most of these multi-story structures have sub-basement or lower level receptors, vaults, including storm, is only required to have a sand interceptor. It's not required to have a sand oil. Going back to your question, does sprinkler pipe in a garage, which is black iron, those threaded connections, do they have oil inside the pipe? Is that residual oil going somewhere? Not really. It discharges a little bit at a time during the test, annual or yearly, and then discharges into a receptor, which is the hub drain. So the question is, should it go through the sand oil interceptor, or should it just go directly to the sanitary? Well, we've gone over this many times, and in our original concept was that it should go through a sand oil interceptor. Because if you take just in this year alone, and you add the 77 plans that I reviewed, not including the 18 that have come in this month, that these all have fire sprinkler systems in them, and they all have to discharge either annual or yearly, and they all have residual oil in them. Where's the oil going? It's going to the wastewater treatment plant. They have to figure out how to get rid of that. But if it has or goes to a sand oil interceptor, there's a little bit of settlement in there. So you remove a little bit of particulate, but it's also a place to house the oil in smaller quantities than to have all of the oils from the sprinkler pipe discharging through the system, bypassing the sand interceptor, which is not a soil in, but it probably would hold the oil, and then go to the sanitary, to the wastewater. Over time, we've decided that because there's not a code that would allow for a sand oil interceptor, that we've backed away from the requirement that it would have to go through a sand oil interceptor, and that it would only necessarily or have to go through or to the sand interceptor. which would probably most likely prevent oils from going further down. So I hope that answers your question. I know it's kind of long-winded, but at the exact same time, we hope to propose the same question to the design community, whether or not this should be a sand oil interceptor and not just a sand interceptor in a parking garage, and see what the community determines whether or not this should be a sand oil interceptor.
The electronic plan submittal you mentioned was based on design contractor input. How do contractors and designers go about voicing their opinion on pushing that forward or not? I know for us, Seattle Plan Review is the only time we really need hard copy drawings other than in the field. So
that's a really good question. So when the development standards are complete and we have the format in play that will not crash our system, we're going to take the development standard information and we're going to send that out to this region's design professionals. We hope to be filtering this through MCA with Ed Comers leading that process, ASPE with Frank Vanderhurst leading that process, and Public Health Seattle King County, Steve Natras and I leading that process, opening up for comment and feedback. If there's enough of a feedback or comment that having paper plan review is outdated or is really a factor in how design professionals operate today, then all this information at that level would be forwarded to management. Those are budgetary issues that we can suggest all day long are a huge benefit to the community as far as customer service goes. As an example, let's say you live out in rural King County and you're putting in a 4-story building. Is it really beneficial to get in your vehicle, drive all the way down to the Chinook building and submit a set of plans and then drive all the way back? The answer to that is, well, no, we don't need another vehicle on the road. We don't need more paper being wasted. And if there was a way to do it electronically, it would be a benefit to not only the submitter, but to the person reviewing. They would just have a queue that they open up and there would be a set of plans to review. So to answer your question in a better way is, if the design community wanted electronic plan review, they would have to voice their opinion that the way that we're doing it right now is not a benefit to the industry. It actually bogs the industry down and makes it look more like government red tape rather than a help. And we will get those review comments out soon, but the first aspect on our part is to create the formatting so it fits into our system, and then import all the data into that system and then send it out for review as if you were actually looking at it on the website, but then commenting on it. So we expect a lot of comment, we expect a lot of feedback, and that would be the time and the place to make your thought known. Are there other questions? No questions in-house? Yes?
So I had a question. You said that Seattle does not show Appendix C, but that it was allowed. I was confused if you could clarify how Appendix C is allowed if it was not shown as part of the Seattle code.
So Chapter 3 of the Uniform Plumbing Code allows alternate engineered designs. And just because an entity like a Public Health Seattle King County or a building department does not specifically adopt an Appendix C, it doesn't mean that that design proposal can't be submitted as an alternate material or modification to the code. So there may not be that actual adoption of that Appendix C, but it doesn't prevent you from moving your proposal forward. And this comes into play with, as I've stated earlier, all types of sustainable systems that have a lot of moving parts that are designed to conserve water or energy. These are not appendice driven, and they're not in the prescriptive body of the code, but they're alternate engineered designs, and Section 301 would point you to that direction for an alternate system.
I just wanted to clarify the Appendix A and Appendix I are in the body of the code book, so they would not need a alternative method.
Anytime that you have a reference to an appendice, you would and can use that as the submittal for the system. It's when we have divisions of mixing and matching code language with appendice. And I'll give you an example. So if you have Appendix C and you are designing a DWV system, and you are using bathroom groups based on probability of use, those sizing criteria, when you are in Appendix C for DWV, this is where you stay. For bathroom groups, for all other fixtures that are not in a bathroom group, you can use the loading, but you can't use the tables to design the system. The tables for design come out of Appendix C. Your question is, can you, or do you have to have an alternate modification request form for using Appendix A or I? And the question is, if it's in the body of the code and it's not referenced, and it says, and continue on with Appendix, then you could submit without having to submit an alternate modification request form. If it says for more information or for further development of your system, go to this Appendix, then you have to submit a modification request form. Because we want to make sure that if you're going to live inside of one Appendix and design your system, that that's where you stay at. What's happened with the current process in Appendix C for DWV, as the example, as soon as the drainage. Is that better?
We'll give it a try.
Okay. As soon as the Appendix, as soon as Appendix C was being used, and they ran out of room going horizontal for the loading, they just jumped over to table 703.2 and used that as their new loading schedule. Well, of course, that fit into the sizing, but we mixed an appendix with a prescriptive code. And it was done by design because they wanted to not increase the pipe size. Well, that's not what Appendix C is for. It's for probability of use for bathroom groups for drainage fixture loading, and table 703.2 is as if it's an entire system design. So, as I stated earlier, only if whatever section you're reading in the code tells you to go for further development of your system, use this Appendix, right? Then you would have to use an AMMRF. Okay. Are there any other questions?
So if you have a multi-use building with residential over commercial, you cannot use the residential Appendix C above with the tables out of Chapter 7 below, is what you were saying in that last comment.
So the question was, if I had a multi-story structure and I had residential above and commercial below, and I wanted to use Appendix C for the multifamily above, and I wanted to use table prescriptively 701, 702.1 and 703.2 for my loading, could I do that? The answer to the question is, if you're in Appendix C, that allowance is already there, but the sizing is out of Appendix C. So in Appendix C, any fixture that's not in a bathroom group, you take the loading out of 7021, but you still use the design of piping out of Appendix C. Now, when that happens, in some instances, the loading is just about the same, with the exception that the building drain and horizontal branch drains and fixture branches and risers are all sized differently in Appendix C. They're completely different, the loading. And you can do other things, 1/8 inch, 1/4 inch, 1/2 inch. So there's different levels of slope that you're allowed to use.
Regarding the detail scale at a 1/4 inch, the requirement for a 1/4 inch scale on the details, would you say that in some cases the scale doesn't apply to the detail because it just maybe blows it up, or it doesn't fit in a 1/4 inch scale? Are you looking for that more for legibility? So if we didn't meet the 1/4 inch on the detail and it was still legible, would that be okay, I guess?
Yeah, so the question was, if I submitted a set of plans and they were not 1/4 scale, but they were other than, let's say they were 1/8 inch, but my design was legible and I could track a system, I would not have an issue with that. And I do receive plans like that, and I do not require them to 1/4 scale. There are projects that are immense in their size. They may be multiple structures over one property area, or they could be a very large building. And in this case, 8 scale would not work. But at the exact same time, if it's a complex system where there's lots of moving parts and pieces to the systems, then what typically happens is having 1/4 scale allows not only myself, but the designer to install or incorporate sections of the structure using a key legend. For example, I have a building and I'm going to break it up into 4 quadrants, 1, 2, 3, and 4. And in my legend, I use 1, 2, 3, or 4. This could still allow multiple systems in one drawing, but at 1/4 scale, but only 1/4 of the project. So the trade-off being that, yeah, it might be 8 scale, but I have multiple sheets, or I have the same amount of sheets at 1/4 scale, but I have multiple systems in each sheet because it's legible and trackable.
Can the speaker please turn their mic on?
Oh, okay, you gotta push it. Keep it.
Okay, so the question was, if I have a sheet, which is typically the last sheet of these sheets, which is construction details. His original question I misunderstood, but the question that he's asking is, does this particular sheet have to have all the details at 1/4 scale? It doesn't have to be 1/4 scale. They can be not to scale. We put 1/4 scale in there for complex systems. If it's not a complex system, then there's no need for it. Not to scale will work, provided that you're not trying to put 35 details on one sheet. I've seen near that amount on a sheet before. More questions? Anybody online got a question?
I just had one more. So I heard that one of my designers was saying that if you have a floor drain that is in a slab and it's a ways from a wall and you run a horizontal vent typically over to a wall, that's not allowed, that you want to move the floor drain closer to the walls. That way you can vent straight out the pipe up through the wall. Is that correct?
Correct. So the question was, is horizontal venting allowed? Well, It is. It's allowed in section 905.3. But it's also allowed under the allowance by the authority having jurisdiction. In addition to that comment, we have on our website the correct way to install a horizontal vent when allowed to have a horizontal vent. So horizontal vents, when used below the flood level rim of a fixture, have to be drainage type, with slope, with clean out. This is kind of common knowledge, but some things that have started to creep into our code change how we look at things today. One of those changes is circuit venting. Circuit venting is a single vent type system that will vent a multiple of battery of fixtures, up to 8. When you have a circuit vent and you are going to say you wanted to run a circuit vent horizontal below the slab, just for starters, a circuit vent is not allowed to run horizontal at any time until it's above the flood level rim of the highest fixture of the system that it's connected to, of the circuit vented branch. The purpose behind that is so that this is the only vent. It's got to stay clear. So if there was a stoppage and solids backed up into the horizontal vent, we know that when stoppages move out or evacuate a system, the stoppages move slower. The solids remain at a lower feet per second residual removing rate than the fluids. And in most cases, the solids would stay in the vent. So if there's a poorly designed system or somebody overuses a system or whatever the case may be, continuing stoppages eventually will block off a vent unless you go and clean it out. But you don't know that you need to clean it out unless you have an issue. Now, does that mean that we prevent people from doing horizontal venting? The answer to that question is no. We do allow it. However, we do not consider a slab a structural condition. If your fixture and your vent are on two sides of a 12-inch by 24-inch web beam, that's a structural obstruction. No one's going to let you cut through a beam just for a drain or a vent. So that's an example. If you had a bond beam in a groundwork, no one's going to let you bisect that or traverse it if it's a bearing point load beam. So that would be another time when we would say, all right, maybe that's an issue right there. You're going to have to horizontal vent because you can't get over to that wall from here. In almost all cases, you can vertical your vent. Places where that they do not allow it, City of Tacoma, City of Bellevue, they do not allow it, and they haven't for a long time. Yet here in our community, we have a reason for wanting to not do it. Theirs is past history. Up to date, ours is a reason for it, and that is because we have circuit venting that's right around the corner. It's in the body of the code, and it's little understood. And as we continue to go down this road, we don't want to get the impression of those that are installing circuit vent systems that they can horizontal vent that, because it's the only vent for 8 fixtures. Are there any questions? Are there any questions online?
Awesome. Well, thank you, Steve, for coming and talking to us. And thank you, everybody who came in person, everybody who signed in online. I'm really excited about how this turned out for our first TAC event of the year. So thanks again. And I will make sure all of that information that Steve mentioned today, from the dog run info, my info for TAC, as well as Steve's info, website, and further resources, are posted with this webinar afterwards. And that'll be available on the ASHRAE site, and I'll make sure that that's posted and available for everybody. Again, thank you for coming. And if you have any questions, feel free to reach out to me at TAC, TAC, at PugetSoundAshRAE.org. And I'd be happy to get back to you. All right, thanks. Have a great day, guys.